So this is our step second. That's how we'll make the basic amplifier circuit or amplifier without feedback. But we have to consider the loading of the each and every component. Okay, it is not as simple as you may think that we just have to remove the feedback. No, we have to remove the feedback, and simultaneously we have to consider the loading of each and every component. Okay, for doing this we will have to follow these steps. Okay, so this is our step second. That's how we will make the basic amplifier circuit as it was without feedback. Okay, so now after that, in our step third, it is a very simple step. You just have to convert the input signal source. If we are considering voltage quantity in the input circuit, we have to use Thevenin equivalent of the source, and if we are considering the current quantity, we have to use the Norton equivalent source. Okay, well, then after that, in step 4 we have to draw the proper model for each active device. For example, in case of BJT, if we are working in low frequency small signal, we have to use H parameter model, and in case of high frequency we have to use hybrid pi model for the BJT. Okay, and in case of FET, for low frequency small signal, we have to use small signal model of the FET. Okay, so well, in step 4 we just have to draw the proper equivalent circuit model of the each and every active device present in the circuit. Okay, after that, in step 5 we have to mark the output. We have to mark the output signal X0, whether it is V0 or I0, depending upon the topology type of sampling signal. We just have to mark V0 or I0. In case of voltage sampling, we will mark it V0, and in case of current sampling, we will mark it I0. Okay, and the feedback signal XF. If the mixing is of series type, we will mark VF, and in case of shunt mixing, we will mark IF. So in this step, we will have to mark the output signal X0, whether it is V0 or I0, and the feedback signal XF, whether it is VF or IF. After that, we will have to evaluate the feedback factor beta. What is beta? Beta is basically XF upon X0, feedback signal upon output signal. This value of beta we have already calculated in our step 1 in the identification of the topology, when we have mathematically proved the type of the topology. Okay, that value of beta and this value of beta will come equal. Okay, but in step 6 still we have to find the value of beta again. Okay, after that we will find the value of A. What is A? A is open loop gain. Well, in case of voltage series topology, we will find AV. In case of current shunt, we will find AI. In case of voltage shunt, we will find RM, and in case of current series, we will find GM. Okay, why are we doing this? Because let us take voltage series feedback topology. Well, in case of voltage series feedback topology, it is AV which will be stabilized. Okay, with the help of this AV, we will find we may find any other gain if we required. Okay, but as a necessary gain, we will find AV for voltage series and AI for current shunt, and similarly for other topologies. Okay, well, in step 8, now from the above values of A and beta, we'll find D, AF, RIF, and ROF dash. Means up to step 7 we have uh, found or calculated all the values we may need in our step 8. With the help of those values of A and beta, we'll find first D. What is D? D is basically D sensitivity equal to 1 plus A beta. AF we already know, AF is A upon 1 plus A beta. RIF and ROF dash. These quantities, these input and output resistances we have already derived in our previous session for each and every feedback topology. Those expressions we will directly use here to find the value of input and output resistances with feedback. Okay, so this is the complete procedure to do the analysis of negative feedback amplifier. Means what does analysis mean? Analysis mean we have to find the value of gain of the given circuit, its input resistance, its output resistance with including load. Okay, so for doing this we have to follow these steps. Okay, so thanks for now. In next session we will take one circuit from each topology and we'll analyze that circuit with the help of these steps. Okay, so thanks for now. We'll meet in our next session.